everyone, welcome back to my channel, LeetCode. And today let's practice a Google interview question, finding the number of visible mountains. So we are given a zero index to the array peaks, where the peaks x, y, stat, the mountain I has a peak at coordinates xi and yi. A mountain can be described as a right-angled isosceles triangle, which is based along the x-axis, and a right angle is its peak. More formally, the gradients of ascending and descending the mountain are 1 and -1 respectively. A mountain is considered visible if its peak does not lie within another mountain, so including the border of other mountains. And it wants us to return the number of visible mountains. So here in example 1, there are 3 mountains here. Mountain 1, the peak here is on the border of the mountain 2, right? So the visible mountains here are only 2. So first, let us know, how do we know if a mountain is within another mountain, or if a triangle is within another triangle? Whole of this triangle within this one, right? Triangle 1 is within the triangle 2, and in this way we can assure that the peak of number 1 mountain is inside mountain 2. If we can get the range, this one, if this one, the width of mountain 1 is within the width of mountain 2, like within the range, the width of mountain 2, and we know that mountain 1 is within mountain 2, then how do we get the coordinates of these 2 points? Of these points, and this point, right? So since we know the mountain here is right angle isosceles triangle, it means that the height of the mountain is about the half size of his width. These 2 have the same length. So since we know the peak, the coordinates of the peak x, and y, then we can get the points here. It should be x plus y, because these are the same size, so it is x plus y and 0. And here the coordinate is x minus y and 0. Now we can change from a 2D plane perspectives into a linear aligned perspective. So what I mean is that let's consider this line. So this line is a 1D version of the mountains here. So we have 0, 1. So first we have the mountain 1, and this one is 0, right? So it starts from 0 and it goes to 4. For mountain 2, the width of the mountain starts from 1 and ends at 9. And for mountain 1, it starts from 3 and ends at 9. the problem becomes easier. So how do we know if any of the lines here overlap with each other? So first, we can sort the mountains, and then we start from the leftmost point. Now, for this example, it is 0. So, and from 0, we know it will goes from 0 to 4. Okay, so now the end or the maximum right, the most right point is 4. And then we have a point, it starts from 1, then it goes to 9. Since this point 9 is out of the rightmost point 4, so we now have a point, the rightmost point, it is 9. Okay, so we only consider the rightmost point 9, and we don't consider its left point 1. Why? Because since the lines are already sorted, and we know that the 1 is on the right or of the list 0, so we know that this part from 1 to this part to the 4 is, of course, it will overlap with the original line here. So we only consider it will overlap this part. So we will only consider the rightmost point. And okay, and every time we expand our rightmost point, we will have a count variable, and we will count the variable and plus by 1. So now is 2. It means the mountains, the number of visible mountains. Now let's go to another line that is from 3 goes to 9. Since the right boundary of this line is also 9, which is the rightmost point here. So we won't consider this mountain 3 as a visible mountain. So we will have a count that is 2. And now let's think about other example. Let's start from this line, right? And now we know the rightmost point is here. And then we will count this as 1 mountain. And then we will go to the next one. So it goes from this one to this one. Okay. Since we will extend our rightmost point, then we will also increase the count by 1, and then it goes to 2. And then we will go to this point. So interesting is that the right point of this line is here. It is smaller than currently rightmost point. It means that this line is overlapping entirely, or it is shadowed by this line. So this mountain is not visible to us. And in this example, we will have 2 visible mountains. Okay, so for the coding part, first let us turn the peaks from a 2D a plane perspectives into a line perspectives. So for the peaks, and we want only the left point and the right point of the triangle. So the left point should be so first we want to have a x and y. The left point is x minus y, and the right point equals to x plus y. Okay. And then we want to sort the peaks. So first, we want to sort the peak by its left point, but there is an interesting edge case that I didn't explain in previous video, is that if now we have 2 points that have the same left point, the same left boundary, and then in this way, we want to process the wider line before the smaller line. So in this way, we will only increase the count by 1. But if we reverse the order and then we process the smaller line before the wider line, and then we will increase the count by 2, because we will like to have to push the rightmost point twice, and we will increase the count by 2. But actually, since they have the same leftmost point, it means that the smaller line is actually within the wider line, so we should only increase the count by 1 only. So here we not only have to sort the peaks by his left point ascendingly, we also want to sort his with the right point descendingly. So next, we want to sort this one descendingly. Okay, and then we want to iterate through all the peaks. And before that, let's initialize the count variable to 0, and the max, or the, okay, I just say the rightmost point, and let's initialize it some minimum number. Okay. And for the index, i.e. the peak, so we have 2 points, x1 and x2 from the peak, and if the x2 is bigger than the current rightmost, I like to replace this with the x2, and then we want to increase the count by 1. Yeah, but before we increase the count, actually we also need to check if there is some same points in the peaks. So if I is smaller than the that is true, we don't want to increase the count by 1. So we just continue, and then if there is no repeated points, then we increase the count by 1. Then let's just return the count. Okay, and let's submit. Okay, cool.